Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so you should check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode to get a $20 credit and launch a new server in under a minute. And for complete visibility into the health of your pipeline, including deployment tracking and powerful alerting driven by machine learning, Datadog has got you covered. With their monitoring, metrics, and log collection agent, including extensive integrations and distributed tracing, you'll have everything you need to find and fix performance bottlenecks in no time. Go to dataengineeringpodcast.com/Datadog today to start your free 14-day trial and get a sweet new t-shirt. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. Your host is Tobias Macy, and today I'm interviewing Christopher Ryan and Hitoshi Harada about MarketStore, a storage server for large volumes of financial time series data. So, Christopher, could you start by introducing yourself?
Hi, yeah. I'm Chris. I work for Alapaca, lead software engineer, and one of the developers on MarketStore.
Hi, this is Hitoshi Harada. I'm a CTO of Alapaca and co-founder of the company.
And starting with you again, Christopher, how did you first get involved in the area of data management?
Well, I come from a background of actually aerospace engineering and slowly made my way into data management, working for IBM on the DB2 replication team for a while, and then, made my way here and started working on MarketStore almost on day one after starting working with Alapaca.
And Hitoshi, how did you get involved?
And so this company Alapaca, and the first application of this financial trading space, I saw the needs for this large volume time series database designed specifically for this particular domain. And so I pitched the idea to Chris and the other developers, and that's how we started.
He's being a little bit modest, but he's also a pretty strong contributor to the Postgres open source too. So he has a strong background in database and storage.
Right. So maybe I should mention that.
Yeah.
So I started my database career path from contributing the code to the open source Postgres community, and I'm the major contributor. I was a major contributor in around the 8.4 and 9.0. Developing the window functions and so on. And then I moved to US from Japan to join distributed database company called Greenplum, and there I served as a main architect of the Greenplum database, touching every piece of the huge database software in query processing and distributed transaction replication and so on. So that's my background, and that's how I got this idea of building some new idea of the database from scratch.
Yeah, generally the sort of general best practice is not to build your own database, but if you have that much domain knowledge and experience on the team, then I can see that you can fairly easily ignore that advice, which it seems that you did when you built MarketStore. So you mentioned that one of the reasons for building it is to be able to handle the financial data. So I'm wondering if you can just talk a bit about the decision behind actually getting the project started, and what are the characteristics of the types of data that you're using that made it such a challenge to manage?
Yeah, so in the beginning, I'll give you a little background about what we do. We predominantly were working in this algo trading space, and we'd have customers writing algos on our platform and would need to very quickly back test those algorithms using, and in the beginning it was only using currency data. Back test probably 10 years of those 1 minute OHLCV or OHLC bars for a given algorithm. And, we're trying to, first we started just storing that in HDF5 files and then querying it through that. And that was taking way too long. And then there was a kind of an in-between step going to MarketStore of trying to query it through a Python implementation, since most of our other stuff was built in Python. And that was chewing through so much memory and still not giving us the performance we wanted. And then we said, okay, we need to go from scratch, start something here to deliver this kind of, for example, 10 years of 1 minute bar data in less than a second to be able to run these back tests and then also do live testing and things like that in the algo trading space.
Yeah, and so your You mentioned that, so yeah, it's not a good idea to start a database product from scratch in any case, and that's also the case here. But so I knew that from my experience background, I knew that how hard it is to build and deliver the production quality database from scratch. But I also knew that if you focus on one thing and just do a good job for this particular use case, I could see how it could be possible to do it that way. And also the modern, so most of the existing traditional databases, for the performance reason, they're being written in a C or those low high cost languages in terms of the development, but we chose the language Go to achieve the best performance and build the high performance database from scratch in a very quick way.
And did you already have a lot of experienced Go developers on the team, or was that something that you ramped up on as you were working on the project?
I mean, for me, I hadn't written any Go before I started working here. I come from a C++ background, and so, but I really took to it. I think, Hitoshi, you had a little bit of experience before.
Yeah. So the Go was, I saw Go evolving over time, and I like the language, simplicity of the language, and that time, lots of people started using Go for more in different areas, but also see more coming from the web application layer. But I personally was seeing the potential of Go language using this kind of low layer middleware type of the use case, and our requirements, the Go fit our requirements perfectly.
And in terms of the actual data that you're storing in MarketStore, I'm wondering if you can give a sense of what the shape of the data looks like and why you decided to build your own storage layer rather than relying on any existing time series databases or document store or anything along those lines.
So predominantly what we're storing are open, high, low, close volume bars. We also do some storage of ticks that come across the wire and then aggregate those as well. Yeah, as far as we wanted to, when we looked at building the storage layer, it was all about optimizing it for our specific use case. We wanted the database to be very focused on what we were using it for, because it just made it much cleaner to work with in, again, the algo trading space that we're in. Quickly load that into a Pandas data frame, do some deep learning testing on it or whatever else that the user wants to do with it.
Yeah, and so of course, the time series database, it wasn't new at all, and not today. And there are many other time series databases. The main thing that we bumped into this is most of the time series database is designed for general purpose use cases, and especially I saw in the coming age of the IoT and sensor data. So they some of the products focus on the sensor data, some of the products focus on more a matrix type of the data, monitoring the IT systems data and so on. And typically the storage format is more like a JSON or binary serialized version of the unstructured data. When it comes to this financial market data, it's pretty structured, as Chris just mentioned. And so the format has to be more optimal. And that way, you don't have to worry much about having hundreds of distributed nodes. It doesn't fit to a normal size of the main memory of the model machine, but definitely that's something easy to put it in the disk and read it at the optimal speed. And yeah, so we looked at different products before jumping into this building from scratch phase, including InfluxDB and other evolving the time series data, but including Hadoop as well. But it made more sense that we build something just optimized for this data. Yeah, so the challenging aspect of not just building, but this particular domain was again so this typical use case is requires both low latency query and deep long history volumic historic query. So what it means is, as Chris briefly mentioned, our application is mainly around the algo trading, and that does both backtesting and live trading. So when it comes to the backtesting, of course, like you need a long history, and the faster you can query, the faster you can see the results quickly. And so like the existing backtest framework we looked at using some of the other data format was like kind of slow because of this data issues in a way. And also once you satisfy this backtest results, then like algo needs to run against the real-time market, and algo needs to be react quickly with the market changes. So from the traditional database, again, like traditional database best practice is that like you should separate those different requirements. Like for the big data, for the like analytical use cases, you should have something like a Hadoop. And for the like more like a rapid type of the fast data, you should have something else like in-memory distributed database or something. But like this, like not just to focus on this particular area and provide the best, the same interface, same functionality, same like experience, having this one a dedicated database server for this particular financial market data was one of the challenges that we saw.
And also in terms of the feature set, one of the things that I saw that I found interesting was that the specific time series had different time zones associated with them based on which markets the data was coming from, which I imagine would be difficult to support in any of the other existing time series databases. And also your mention of needing to be able to maintain a long history, whereas a lot of particularly metrics-oriented time series databases have a feature where they automatically compact the data after it exceeds a particular time horizon, where you definitely don't want to do that because of that need to be able to do granular analysis of the algorithm across various time horizons into the past for doing the back testing.
Exactly, yeah. Depending, and not just different markets, but also just different securities and things you want to store. You know, a currency, just there is no market close on currency data or crypto data too now. And then, you know, all of our U.S. equity data needs to be on Eastern time zone and be aggregated to that time frame. And then there's also after hours data that we also want to include, but doesn't get included in the aggregated one day bar for that day. You know, so there were a lot of unique challenges to that finance realm that we felt needed a specialized approach.
And you said, too, that when you were first getting started with building the Alapaca data stack, that you were originally using HDF5 files for doing the analysis. So I'm wondering how the overall workflow changed from what you were using to what it is now that you have MarketStore available as that single source of data for those financial markets.
Yeah, I mean, it was kind of night and day. Yeah, it was... We now we just have, you know, a MarketStore running or a couple MarketStores running, and then they're just openly available. You know, we have a dev environment one as well as our production, and they're openly available for query at any time. So anybody can now just, okay, I need to backtest for 10 years of data right now in my little IPython client with this little algo that I came up with. And, you know, you're able to do that really quickly, and it's all queried via JSON RPC. So, yeah, it has made things much, much faster. There's no, like, moving the data around. Oh, I have an HDF5 file over here, and I need to bring it over here and now parse it and all this stuff.
Yeah, like before MarketStore, like we used to have lots of HDFS file here and there on disk locally, as well as in S3.
S3 bills are down.
Yeah, and download it like every time it needs. And also, it was very hard. So one of the challenging part in the HTML file was keep appending the new data at the end as time goes. And like I found that the data frame or HDFS file was not designed for that. So that's and then like today. With the MarketStore, it's fairly like quick to update, and we don't care. Like we don't notice that like there's any performance issues at all. And also, so again, like, so the main client's application is like Python-based application with the PyData framework, with the Dataframe, and also like using the machine learning stuff. So like MarketStore is returns most of like the binary format, like in a JSON RPC in a way, but also in a message back in a binary protocol, and sends the most optimal like C array style of the data directly to the client, and client just decodes it to the data frame. So you barely notice actually, like from the application perspective, you barely notice that there's any difference from like just reading the HTTPS file from disk, or even faster to read it from MarketStore.
And we've talked a bit about the fact that the actual financial data that's being loaded into MarketStore is coming from external services. So I'm wondering what mechanisms you have for being able to maintain an up-to-date record of that data as it is generated, and how you are able to ensure that any queries that are executed at a given point in time are using the most up-to-date data that's available.
Yeah, that's been a challenge, and part of the reason that we built MarketStore too was that these upstream providers weren't delivering the performance that we needed to query from them for our use case. So we would have liked to just say, hey, okay, you guys have the data, we'll pay you this, and then we can query our 10 years of that data anytime we want. Well, that's not the case. That's going to take you like 30 minutes sometimes to query that data, and it just didn't make sense. So instead, we obviously keep our stores, our history stored in the database, and then we're constantly appending new records from the upstream. And unfortunately, also many of these providers are not the most modern of API, don't have the most modern of APIs. So we end up having to just pull from a lot of them. Some of them are now adding streaming services, but it's a slow process. So in between MarketStore, because we wanted to keep MarketStore just as the database itself, and then we added a plugin interface to be able to have kind of add-ons for things that people want to do with it. So one of those add-ons we created is called the Slate plugin, which is actually a plugin that connects to another open source project that we worked on, which was just an in-memory cache called Slate. And so we are constantly pulling from this upstream, and then it goes into this in-memory cache where we're also keeping real-time quotes, because besides from the historical data that we store in MarketStore, we need to provide real-time quotes to our clients too, and just a snapshot as quickly as possible of the current market price of any given security. And then that data is then streamed from there through the plugin onto disk throughout the day. And so it's a pretty big issue that we've spent a lot of time working on, trying to get that flow as clean as possible.
And given the fact that the majority, if not all, of the data that's being stored in MarketStore is actually coming from these external sources, what is the impact if the instance that's holding MarketStore just has a catastrophic failure? Do you have any guards in place for ensuring any sort of point-in-time recovery, or would it just be a matter of build a new instance and then reload the data from those external sources?
Yeah, so right now we're on our production server. We're actually running two completely separate instances with separate cloud deployments, and have completely mirrored data sets. And then the challenge then is keeping those in sync. And we're constantly monitoring that, keeping those in sync. And if one goes down, we have the other as a backup.
Yes, like as a production system, definitely we have to have this redundancy, and we have some like a management operational tool set that maintains the data incorrect and perform the cross consistency as well. And Slate, like having this Slate in between is also one of our best practices to keep up running the MarketStore as well. So Slate is kind of cache, but also like you can think of like a lightweight version of the Kafka, and so that's a message bus. So because it's an external source, like we keep pulling it, but just once, and keep it in between Slate. And one of the good features in Slate is you can also query short amount of the latest history, not just the consuming the real-time messages. So the market store is like in the case of like one market store fails, we just bring it back and it catches up to the latest history through this rate. So we don't have anything. So at this moment, MarketStore itself doesn't have any built-in replication or nice feature or this recovery kind of feature that like most of the database have. But rather like we just keep polling it and make sure that it can catch up in a short amount of the time failure. Yeah, but like by itself, in MarketStore itself, we also have write-ahead transaction mainly for the performance reason because of writing into a different bunch of the partition of the time series. Like you can see like the performance overhead. So like the MarketStore writes the data in the wall, but this wall write-ahead log can also help the durability and the transaction consistency as well. So in a way, like so, in a quick panic or crash type of the failure, if it happens, then MarketStore can constantly recovers by its own, and if it lags in terms of data, then it can catch up by the help of the Slate.
And since MarketStore is being used for querying and analyzing data that has to do with financial markets, and there might be large quantities of money being staked on the result of that analysis, what kinds of mechanisms do you have in place, whether it's unit testing at the code level or doing comparative testing against the raw data sources? How do you ensure that the operations that are being performed in MarketStore are returning accurate and repeatable results?
Yeah, I mean, of course, it starts at the low level with the unit testing. We try to be as diligent as possible and be that test-driven development kind of a shop. But also, we use individual instances of MarketStore in our own integration testing with our systems all the time. So, like on Circle CI, we'll spin up a Slate, a MarketStore, and then our application that's running those tests with the data that's delivered from MarketStore. So, we're constantly testing how the data is being delivered, and if that data isn't exactly as it's supposed to be, then our algorithms backtest will come out with a different result, and we'll know that right away.
And also from a security perspective, what mechanisms do you have in place to ensure that the data in MarketStore isn't being tampered with by some malicious actor?
As of right now, we don't have any security kind of add-ins to MarketStore. What we're doing right now is it's completely internal. It's not exposed to the outside for query. We're proxying it through our own server.
And what have been some of the most challenging aspects, whether technical or otherwise, in terms of building and maintaining the MarketStore project and integrating it into the rest of your systems?
I mean, it's been great and successful, at least within our system. For us, one of the challenges we have is we are not selling this product to any customers. I mean, this is a part of strong backbone for the trading space. But unlike other companies who builds a company along with this database product, the challenge is how we can keep up this open source and provide a good value to the rest of the community. If it's we sometimes focus entire engineering team needs to focus on our delivery, and that doesn't include the MarketStore itself, right? So how we keep improving the product, and also if someone needs some help using MarketStore, how we can allocate those engineering resources and help them. And maybe we don't have the clear answer yet, but maybe it's more to have strong community building it and talk about it in some other meetups and so on. But that's one of the things we are seeing.
And you mentioned there too the fact that the project is open source, which I don't know if we had mentioned earlier. So I'm wondering if you can talk a bit about your reasoning for releasing the project as open source, and whether there was any particular cleanup needed to be able to release the project publicly.
The history is so like we started from like building it from scratch and like just for the internal use case, and we made it for like as a proprietary first at the beginning. But like as we progress and work with the many other type of the people, including those upstream data source providers and similar companies who try to build something like a application in this trading space. We constantly saw the same needs for this, and we still wonder like how they are doing. Like I heard some of the traditional like brokerage company just like builds this similar type of the workload using SQL database, which kind of like ridiculous to me. But so one of the things that we compare with the existing brokerage API in terms of data streaming is data query for the historical data was like what was it like MarketStore returned the data for the last year at the minute level was 20 milliseconds or something, and their API returned in 4 minutes or so. Yeah, but anyway. So what was the point?
Why are we open source?
Yeah, why open source? Yeah. Right. So again, so like this is the same path that everyone goes, and even like after announcing the open source, I was contacted by one of my old friends who is also personally doing the algo trading, and he mentioned that this is great. Like I had to build something. A smaller version of this, like by myself, and so on. So, and for us, it's not just given to the community. Of course, like buying, like open sourcing gives us a lot of course, one of the things is marketing as a company, but also like a development resource contribution. Like we are totally welcome. Like if someone wants to contribute and even like see. Like we want to see more like use cases, what kind of thing they want, and constantly keep improving our products is a great thing. So again, like from my traditional relational database product experience, at this point of time, database being open source is a natural thing. So the Oracle and those proprietary database code source doesn't make any sense to the users at all. They need to see like inside what's inside, even if it's paid software. Like you still like the open sourcing and having the contribution, see more use cases, listen to the users is a very important thing.
Yeah, and I mean, if somebody opens an issue on our GitHub repo for MarketStore, it gives us insight into what these people are using it for. Maybe something that we haven't thought of before. And maybe that's something that we can incorporate into our product going forward in the algo trading space. It's almost like user testing, sort of, by proxy.
And what are some of the upcoming features that you have planned for MarketStore and any particular use cases that those features might be aimed at?
Sure, yeah. Actually, when there was a proprietary database, we already had this feature, and then we decided to strip it out for the open source release. But as we mentioned before, we do the back testing on these algorithms, but also people were wanting to live test and actually run and place trades live. So in order for an algorithm to have, maintain correct state, not only of its holdings and portfolio, but also of the market data itself and what the securities are doing throughout the day, we wanted to add some push capabilities to the system and allow clients to subscribe either to the data that's being directly written or the aggregated data that is being created inside a MarketStore. So if a person's running an algorithm, they can be receiving that 1 minute bar, that 5 minute bar, that 1 hour bar as soon as it's there, and not have to poll or keep querying or all that stuff.
Yeah, particularly in the area of financial trading, being able to have the lowest latency possible for being able to analyze and then execute those trades, I can see as being immensely valuable for the people who are interacting with the service. And so I can see on the client side of being able to retrieve the data, but also in MarketStore, being able to obtain the data from the actual markets themselves, being able to maintain that high throughput, low latency data stream would be immensely useful. And are there any other topics that we didn't talk about yet that you think we should cover?
Not much particular, not much in the MarketStore itself. I just wanted to add that. So on top of those good things about MarketStore, like one of the things, one of the reason that we open source the MarketStore is so this Alapaca's vision and mission, and so like we are seeing like especially in the retail space, retail trading space, so the institutions have become a lot of like algo-oriented trading, and they have a lot of arms and tools. But when it comes to the retail trading space, we constantly see a needs, but like lack of the access to those high quality data, high performance data, and a good amount of the tool set, high sophisticated AI technology. And that's why like we are building this. And of course, like providing data store is not only the thing, but this is like online, like in line with what we want to achieve, which is to say like we want to provide a technology and arms to the retail investors. If they're smart enough and they're good at trading, they should be able to compete with the rest of the world, including institutions. So like again, like we want to see more individual people, developers use the MarketStore, touch it and see it, and how fast they find it useful or not useful, and want to solve those many problems as a company.
And so for anybody who wants to get in touch with either of you and follow the work that you're up to, I'll have you add your preferred contact information to the show notes. And as a final question, I'm wondering if you can share your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I mean, no, like it's great seeing like so many different databases coming up. Like I quickly saw your blog, your series of the podcast, and it's great to see like even in the space of the Timeseries database, there's many new and old, and so and we are happy that like we kind of joined this list as one of the database.
Yeah, I mean, in terms of gap, one of the things that we were looking to fill was getting back to that and why we open sourced it, and this idea of breaking the barriers of entry for people. We didn't want someone to have to be a database or an SQL expert or anything like that to be able to just, okay, I'm going to grab some crypto data from, GDAX or something. I'm going to write it on disk, and then I'm going to just press a button, run MarketStore, and then just start writing some Python. A lot of the other systems out there, it requires you to have this background knowledge of like how to even interact with it. And so and part of it is, we did write something that was specialized, sure, but it also made it easy for somebody who, just has a little bit of Python background or maybe very little Python background to just get started on a project where they think they can make themselves a little bit of money, compete with the big boys at Goldman Sachs or whatever else, and not need to have that background that's often required in the data storage space.
Well, I want to thank the both of you for taking the time out of your day to join me and talk about the work that you're doing at Alapaca and on MarketStore. So it definitely looks like an interesting project and one that I'm sure will see a lot of uptake. So thank you both for that, and I hope you enjoy the rest of your day.
Appreciate it. Thank you.
Thank you.